Hello everyone. In this video, I'm going to solve some problems based on the integration by parts technique. Okay, so our first problem is gonna be the following. Okay, let's integrate the integral of x to the power of 5. All right, ln of x times dx, ln of x dx. Okay, so before going to integrate this by parts, we have to remember the formula. Okay, the formula for the integration by parts is saying that the integral of u dv is equal to, right, the u v minus the integral of v du. All right, this is very important. We have to know this first. Right, now the second step is deciding my u. Okay, deciding my u. Remember, always we give priority for u. All right, so I don't know which one to say u and then dv, but I just have to use the acronym as always, the acronym LIPET. Okay, based on this acronym, so the L is the logarithm, the I is the inverse trig, the polynomial p, exponent e, and then trigonometry, the last one, or t. All right, so if that is the case, now when I look at my first integration, x to the power of 5 ln x dx, all right, so the ln x is gonna be my u. Okay, the ln x is gonna be my u because that's the logarithm. Okay, that's the logarithm, which is the first one. All right, so what I'm gonna do is this. Okay, u, all right, let u is equal to ln x. Once I decide my u, whatever is remaining is gonna be the dv. Okay, whatever remaining over there, everything, okay, everything that remaining after I took my u is gonna be my dv. So that means I can just say dv is equal to x the power of 5 times dx. Okay, x the power of 5 times dx. Very good. Now I have the u, and then I have the dv. All right, so that means I can rewrite the first one in this form, and then I need some u is already there, I need v, and then if I know dv, I just have to find the v. Okay, so what is, if u is ln x and then dv is this one, what is the du, the derivative of u, the derivative of u from that? Okay, if u is ln x, if u is ln x, the derivative u is just 1 over x dx. Okay, don't forget the dx, always 1 over x dx. All right, 1 over x dx. All right, what's next? If dv is x to the power of 5 dx, what is v? All right, what is v again? What is v? All right, what is v? v is gonna be x to the power of 6 over 6. How do I know this one? I can simply integrate the dv. If I want to, I can integrate the dv here, and then I can find x to the power of 6, the power of 6, because that's the antiderivative of the given function. Okay, now I have everything. If I have everything now, go ahead and then plug in one by one. Okay, one by one. So this is gonna be like this. Don't worry about the left side now. The left side of the function is not just the original function. I have to work on the right side. I have to work on the right side. So u is ln x, right? U is ln x, and then v is times x to the power of 6 over 6, x to the power of 6 over 6, right? X to the power of 6 over 6 minus the integral of v du. Okay, v du is x to the power of 6 over 6, that's the v, and then the du is times 1 over x dx. Okay, 1 over x dx. Very good. Now once I substitute it this way, it's becoming a little bit easier. So the first step is very important, to identify my u, my du, and then everybody else very carefully. Okay, now the left side is still easy, but just a matter of rearranging now, a matter of rearranging. This is equal to now, let's keep that one, ln of x into x to the power of 6 over 6 minus, right, minus. So look at the integrand here. Okay, I can do something here. Okay, so this is x to the power of 6. Okay, I have 1x here. That 1x can cancel with just 1x from here, and then in the integral now I will have this, right, x to the power of 5, x to the power of 5 over 6 times dx, because 1x from the numerator cancels with the denominator. I have 6x on the top and then I have 1x at the bottom, right? Very good. So the next step is gonna be this. The next step is gonna be this. Okay, so look at that carefully. Look at that carefully. The ln of x times x to the power of 6 over 6 minus, what is the integral of x to the power of 5 dx? Well, first I can bring this 1 over 6 outside. Okay, this is because this is 1 over 6 times the integral of x to the power of 5 is gonna be x to the power of 6 over 6 plus some constant. Okay, now I can clean up. Okay, it's a matter of clean up now. This is gonna be what, ln of x, right, ln of x times x to the power of 6 over 6 minus, so this is going to be x to the power of 6. 6 times 6 is 36, all right, plus some constant. Okay, so I can just stop at this point because this is enough for this integration. So finally ln x times x to the power of 6 over 6 minus x to the power of 6 over 36 plus c is going to be my final integral. Okay, my final integral. All right, let's continue to the next problem. The next problem is as follows. Okay, the next problem is as follows. Let's move this one up. All right, so the next problem is given as follows. What is the integral of let me take my white pen. The integral of x e the power of 2x dx. Okay, e the power of 2x dx. All right, so still the same fashion. Okay, the same thing means first let your u, all right, your u is gonna be the x. You can say u is equal to x now. Okay, x, and then exponent is the next one according to the limit. Okay, don't forget the limit. So that's gonna be now the remaining, if u is my x and the remaining part is e the power of x dx, is gonna be dv. Okay, I don't have any confusion about dv. Once I decide about my u, whatever is left in the integrand is gonna be my dv. So according to that, e the power of 2x dx is my dv. Okay, this is my dv. All right, so from this now, if I know u, because I need du is equal to simply dx. Okay, simply dx, because the derivative of x is 1 and then 1 dx, so that's 1 dx. Don't forget this dx again and again. All right, now the next is now because I need dv, what is dv? Not what is v, I'm sorry, dv is already known. What is v is the question now, because I have the dv already. What is v? Is simply you integrate the e the power of 2x, and then when integrating that you can use u substitution again for the integral, and then your v is gonna be 1 over 2 the v is 1 over 2 e the power of 2x. Okay, e the power of 2x. Okay, if I integrate dv, let's say for example, if I integrate dv, the integral of e the power of 2x dx. Okay, if I integrate this one, all right, because that's the dv, the integral of dv is just v, and then the integral of e the power of 2x dx is going to be 1 over 2 e the power of 2x. Just your u is going to be let u, you can say let u is equal to 2x, okay, if u is 2x, and then the integral of e the power of u dx, okay. So just you keep going that way, and then you find this one. So anyway, just integrate that, and then you will find your v, okay. You have to know how to integrate this one into the v. All right, now I have everything ready, okay. I have everything ready. I can just go ahead and then substitute everything in my equation, okay. I have everything in my equation equals to, all right. So u dv is equal to u dv is equal to u dv is equal to uv, all right, uv minus the integral of v du, all right, the integral of v du. So this means that what is u? My u is there. What is that? That's the x, all right, the x times what is the v? The v is 1 over 2 e the power of 2x, okay, e the power of 2x, all right, minus the integral of v. What is v? My v is again 1 over 2 e the power of 2x, 1 over 2 e the power of 2x, right? And then du, all right, du is dx, okay, du is dx already from here, times dx, okay, times dx. Very good. Once I rearrange this one this way, the next step is matter of cleanup again, okay. So what I'm gonna do is this, right? This is the left side, okay, the left side is gonna be this x, right? This is the x, and then e the power of 2x simply over 2, right? This is over 2 minus, okay, minus I can take out this 1 over 2 from the integral, this 1 over 2 from the integral, and then that's gonna be 1 over 2 times the integral of e the power of 2x dx, right? Dx. Nice. Now I can integrate this one. I can integrate this one using this form, okay, using this form. This the integral of e the power of 2x dx. What is the integral of e the power of 2x dx? So I can use here a u substitution, okay, a u substitution. That's the only way I can integrate this one. So my u is equal to 2x, right? My u is equal to 2x, and then my du is equal to, what is my du? Because when I integrate this one, that's gonna be 2 dx, and then from this dx is gonna be what? Du over 2, right? So the next step is the following, okay. The next step is the following. I can substitute in my next integral. This one, x e the power of 2x over 2 minus 1 over 2, right? 1 over 2, the integral of e the power of u, because 2x is my u, times du over 2. I just substitute the dx by that, all right? So this is gonna be this one, x e the power of 2x over 2, right, minus, okay, I can take out 1 over 2, which is below the du, so 1 over 2 is here, this 1 over 2, this one is 1 over 2, and then it changes the one outside the integral, 1 over 4, the integral of e the power of u du, right? So this is finally is gonna be like this, x e the power of 2x over 2 minus, all right, 1 over 4 times e the power of u. What is the integral of e the power of x? Is e the power of x. So the same thing is true for this one. So this is gonna be e the power of u plus c, okay, e the power of u plus c. So now let's remember what is my u at the beginning. My u is 2x. Look at my u is 2x on the top. So my u is 2x. So I can substitute that. By substituting that, I'm gonna get x the power of e the power of 2x over 2 plus, sorry, minus, I'm sorry, that's minus e the power of 2x over over 4 plus some constant. Okay, so this is going to be my final answer. It's going to be my final answer. All right. So the next is trig integral. Okay, I will apply some trigonometric functions and identities, and then I will show you about trig integral. Let's go to the next video.